Alright guys, in this video we're going to look at some AP style questions trying to see the differences between resonance structures and formal charge and determining what's the most likely resonance structure. For example, in this first one we have two different Lewis structures of fulminic acid, which is HCNO, and they're both shown below. We are in the question trying to explain why the diagram on the left is the better representation for the bonding in fulminic acid, and we're going to use formal charges to determine that. Okay, so remember for formal charge, it is the valence electrons of that atom or that element minus the non-bonding electrons, and then minus the bonding electrons divided by 2, and that gives you the formal charge. So looking at this H right here, on the far left, we'll go left to right on all of these. There should be 1 valence electron minus 0 non-bonding electrons minus 2 bonding electrons divided by 2. So the formal charge of this hydrogen is 0. In fact, all hydrogens that just have a single bond is just going to have a formal charge of 0, so that makes it nice and easy for the other one. Okay, looking at the carbons now, the carbon on the left, there should be 4 valence electrons in this one, minus 0 non-bonding electrons, minus 8 divided by 2 bonding electrons, so that'll give me a formal charge of 0 here, which is great. This one's going to be different, though. This one will have 4 valence electrons minus 2 non-bonding electrons minus 6 divided by 2 bonding electrons. So that would be 4 minus 2 minus 3, which would give me a minus 1. So we'll have a minus 1 formal charge on this carbon. Okay, looking at the nitrogens in both cases, they're going to be very similar. There should be 5 valence electrons with nitrogen, minus 0 non-bonding electrons, minus 8 divided by 2 bonding electrons. Okay, that's going to be a 4, so 5 minus 4 gives me a plus 1. Plus 1, and in fact, this will be the exact same because we have only 4 bonds around each around that nitrogen, so that will also have a plus 1 formal charge on this side. Finally, we'll look at the oxygens for each one. We will do 6 valence electrons minus 6 non-bonding electrons minus 2 divided by 2 bonding electrons for a total of a minus 1 formal charge here. Looking at this oxygen over here, we'll have 6 minus 4 minus 4 divided by 2, which will be a 0. Okay, so looking between these two Lewis dot structures, the difference is where is the negative charge? Is it going to be on the oxygen or is it going to be on the carbon? Okay, if we're going to choose between two, we're going to choose the more electronegative atom, so oxygen. So that's why the diagram on the left is better. We're putting a formal charge of a minus charge on the oxygen as opposed to the carbon. Okay, and that's because it's more electronegative, it's more likely to hold on to those electrons and make it a more stable Lewis structure. So that's why diagram left is better. We can use formal charge to explain that and our understanding of that electronegativity. Okay, this next one is very similar. We have 3 Lewis diagrams this time. This time we don't know which one is the best. We got to determine which one is the best. So we're going to determine that based by figuring out formal charges, and whichever one is the closest to zeros and has the least amount of positive and negative formal charges is going to be the right answer. We'll start with the aluminums. Looking at this aluminum, there should be 3 valence electrons on aluminum. There will be 0 non-bonding and 6 divided by 2 bonding electrons for a formal charge of 0. That's off to a good start on that one. This one will have 3 minus 2 minus 6 divided by 2. So this one's actually going to have a formal charge of 3 minus 2 minus 3. What is that? 3 minus 5 minus 2. a -2 charge on this aluminum. Not for a good start for that one. Looking at this one, we'll have 3 minus 0 minus 8 divided by 2. That's going to be 3 minus 5, or 4, sorry, so a -1 charge here. So right off the bat, I'm already leaning towards diagram 1. I'm just going to check these chlorines, because these chlorines are all the same formal charge type. If I take 7 minus 6 minus 2 divided by 2 for the bonding electrons, I will get 0. So I have zeros across the board on diagram 1. This one would be my choice. I would say diagram 1 is the best representation for bonding in AlCl3 because all atoms have 0 formal charges, whereas diagrams 2 and 3 would have negative charges and positive charges on their chlorines and aluminums. So definitely going with diagram 1.